Thank you so much, Preston and Elizabeth. At this time, we'll take questions from the judges, and then after the judges go through their questions, we'll open it up to the room. And if you have a question, please come up to the microphone so that everybody can hear you. So we can start with Maria at the corner.
I want to congratulate you on a job very well done, and for the fact that you're here today, so thank you on behalf of all of us. The question goes to the amount of money that I wonder if you have a total amount of money for how much this project would cost. I know that you went through the intersections, mentioning on your presentation today that it would be about $250,000 per railroad crossing according to the Department of Transportation. Is that the Florida Department of Transportation because of the proximity, or which Department of Transportation are you referring to?
The lower capital cost number we did get from the Florida Department of Transportation for just a very simple upgrade to a railroad crossing with basic signaling and pavement markings. The $250,000 to $300,000 number, I believe, came from the Indiana Department of Transportation and perhaps the Minnesota Department of Transportation for a full-scale automatic detection, automatic gates. Because of the lack of availability of data, and quite frankly, there's not a large centralized database of the status of all of the different parts of the railroad network in Cuba, we felt more comfortable giving some of the information regarding what's going to go into the process, but we didn't want to give some sort of generalized number without the correct information behind it. That would be the core part of our research and testing phase with that institute with CUBA and the University of Alabama, where we would actually go through, begin logging the statuses, and then we can go through and begin calculating the actual cost. We don't know the economic factor that goes into the relationships that we have to build and what it's actually going to cost when we get there and try to implement this. So we could just sort of start as a basis of what we know it might cost in the United States. Does that help?
Yes, it does. The next and last question from me is, what are you planning to do for additional safety issues related to this multimodal? And I read in the report that you are assuming that people will take on and off these vehicles at any given location along the corridor. And I wonder if you had looked into other safety issues related to that. And I wonder if...
We had, but we had figured that a lot of this would go into research and it would be dependable upon how each existing intersection was. And I know that one of the main things that we knew that needed to be taken into consideration was the design and the training of the people who are converting these vehicles and who would be constructing them and working on them in Cuba, because it kind of needs to start at the actual vehicle and rail itself. So we would just have to research that and get the numbers from there based upon what we found as the existing conditions.
Thank you.
I would like also to congratulate you, and I'm going to be very brief in my question. Only one question. When you talk about feasibility in your project, you just say feasibility. But feasibility, according to many projects, are feasibility of doing, or actually production feasibility, then economic feasibility and financial feasibility. Where are those other two parts that I don't see, in the project?
I would say we wanted to focus on the proof of concept. This is a very novel idea and doesn't have a true expansive real-world application. We think if someone came up here perhaps 10, 20 years ago and got through that entire process of feasibility with autonomous vehicles and said, this is exactly how it's going to happen, that wouldn't be accurate, because there's not a full body of research yet there available. We wanted to start this process where we can prove that this is a viable option, begin the research and testing phase, and establish these relationships so we can get that information and actually have it be accurate and from in-field experience and testing with our partnership in Cuba. Our focus on the feasibility was from a maintenance and infrastructure perspective. Is the railroad capable of supporting these vehicles? That was our focus.
But remember that it says economic analysis, and I don't see economic analysis in your project. So
Again, I want to congratulate you on the presentation. Uh, I had basically two questions. Following up on the economics, did you do a cost comparison between doing this and just adding buses in Cuba? Because the problem with the public transportation in Cuba is not that the streets are overcrowded and you can't fit. The problem is they don't have any buses. So did you do any cost comparison between just adding buses and doing this dual mode?
We didn't, but we felt that adding buses would just add to the existing congestion on the roads, and essentially you would either be waiting on the bus in traffic or waiting at the stop for another bus to come.
So then the other question, okay, go ahead.
Well, and I do want to emphasize that we did not look into buses. We really do feel like we wanted to take a new, innovative approach. We could do a bus design and do a bus transit system like many cities have across the world that function much better than Havana and in other places. We want to take a new idea and get away from sort of the traditional transportation planning aspects and propose a new system to complement some of these transportation systems.
Okay, now the other question is, how do you handle north-south traffic? Because you only got one rail. So you can't have everybody going south at the same time or everybody going north at the same time. How do you do?
So we have one rail line represented on there in the geographic information system, but when you actually zoom in closer, there are portions of the track where there are multiple tracks, there are multiple different sizes, but because they are high rail vehicles, they can get off the tracks in different portions. So maybe for a small portion, if there were single tracking, which in more detail in our geographic information system, we can actually build and tell where those portions are, where they might have to more often actually utilize the road network for certain parts of the rail, and then get up to those corridors where there are multiple tracks, get on transfer stations there, and get back on the tracks. It's sort of a more fluid system where it can flex between the road network and the rail network is the point. So it's not just a traditional personal rapid transit rail only, or just a vehicle only on the road network. They can transfer at different points.
Thank you.
Again, congratulations, as most of the other judges have mentioned. I guess I have three basic questions, and one of your answers may have covered it already, but you mentioned before that your prior project that you had, the expansion of the BRT system, if you will, created more problems than it would solve. Could you comment on that a little bit and tell me why you decided to go with this solution as opposed to whatever the other issues were with the other one, because I'm not familiar with it?
Yes, last year we had projected a bus rapid transit system, and we would convert existing lanes to be the stations. And after we went back through and looked at it, we realized that it would probably create more issues because it would be taking away from lanes. And with the projected ridership, it would probably cause more congestion on the roads due to the taking over of the lanes.
Okay, thank you. With respect to the current railroad track that is currently there, is it currently being utilized by rail traffic? And if so, how do you coordinate the movement of the high rail in and out with the train traffic that might go through the rail system?
We don't have existing timetables of the freight or if there's any level of passenger traffic there. There are existing stations where it stops at the northern terminus is some sort of supposedly a passenger station. We don't know how much it's in use, but we do know how the high rail vehicles, the maintenance trucks in America function when they operate here. They have a series of radio control. It's actually not using autonomy or anything related to cell phone signals. They're using some sort of radio signal where they're back and forth between a centralized headquarters that gives them more or less timetables of here's your window that you have to operate on the corridor. And so we want to function similar to that, like the maintenance trucks in America do function, where there are these windows where we can use our dual mode transit, and when it's not available, it can flex to the road network to not be using it when it's necessary for freight, other passenger projects, and things like that.
Okay, go ahead, I'm sorry.
Oh, and this would also be addressed during the upgrades of the intersections. Depending on the funding for the particular intersection, there could be sensors installed or other forms of technology to alert so everyone knows which type of vehicle is coming.
Okay. One final question, since you mentioned before that one of the issues in Cuba is the existing bus system has reliability issues, and what you're introducing here in high rail transportation, it's a more complex system, if you will, in terms of having tires and the high rail portion of it. What are your expectations regarding reliability of this system vis-a-vis a bus system?
We don't know the specific technical aspects in great detail of all of the technology that goes into it. That would be why we feel like it's very important. One of the partnerships we mentioned would be the mechanical engineering faculty at CUHI, as well as there are a couple institutes within the Alabama Transportation Center where they could get into maybe perhaps vehicle reliability, more so that we know more perhaps about the system approach to it. From what I know of the actual technology of high-rail vehicle, there's a very simple form of it where there's no electronic or hydraulic components where it's actually implemented, so there's no chance to have some sort of shortage or anything related to that. We would probably start with the very base level of that and move forward from there. But it would require the testing phase of finding out perhaps in small corridors near CUHI before we expand it on to see where are those issues and what are we having issues in the system, what's taking too long, what isn't reliable, and move forward from there.
Thank you.
Thank you, judges. Any questions from within the audience here today? Please use the microphone.
Hello. My question is pretty much about safety and actually logistics of operating the system. You're talking about over 20,000 people using the system and about 5 people per vehicle average. How would you control these vehicles entering and exiting the stations in a safety way, and also the ridership as you go along seems to be quite big for the load that rail can take.
So is your question safety issues related to passengers getting in and out of the system, essentially?
More the vehicles getting into the rail and actually getting out of the rail and riding on the rail.
So we imagine that the railroad crossings would be those transfer stations where they're able to convert and essentially transfer between the road and rail aspect. I believe back on the picture with the Hokkaido DMV vehicle there, the dual mode vehicle, it was less than a minute time that it actually takes to transition between. That specific vehicle technology essentially just drives through something that lifts and changes it. We don't know exactly the difference in times for the more adaptive vehicle times, but they would have to have enough time either between the gate or just off the road to have a separate like entrance right there, and then drop the technology and then go in. We don't know the exact timing that would take. We just have the example from the dual mode vehicle in Japan, which I know was a very short time for that system.
Okay, and the second part was actually about riding along the path. How do you control your vehicle stopping or slowing down and then accelerating on that rail? Seems to be a logistic problem there.
The controls are actually from the vehicle itself. So the rolling stock goes down and makes it adaptable to drive on the rails. But for instance, the maintenance trucks in America, when they're operating on there, it's powered by the truck, and they're the ones that are, the way that it's integrated with the braking and accelerating system, it's actually self-controlled.
Thank you, Rafael.
Any other questions? Bert?
Good morning. Similar to what the what the judges said, congratulations. You put a lot of thought into this and did a great job. So, thank you. My question is more related to the cultural aspects of it. In Japan, you have a very, first of all, what they've done in Japan is mostly a tourist kind of dual mode vehicle, right, that runs along the bay. And so it's meant for tourists to kind of have a scenic view, and then you take them on off the road. Knowing a little bit about the Japanese, how structured they are, how disciplined they are, I worry about the cultural aspects of implementing such a system to people who have kind of not perhaps been aware of technology and structured approach to traffic, et cetera, and not just Cubans, but Latins in general. So my thought is, did you think about the cultural aspects of implementing a system, the discipline that it would take in the individuals, and was that a consideration in why you selected this approach? And if so, how did you think of that?
Well, we figured this would be addressed in the early testing stages once we began running trials in Havana regarding this matter. And also, I know it was similar assumptions were made when Uber was first introduced to the United States, where people were hesitant to ride in other cars with people they didn't know in just a different taxi service. So in the early stages, there could be discounts such as Uber did, or incentives or free rides to introduce the public, a slow introduction to how it is a feasible option and a different option, but it still gets them from point A to point B in a quicker amount of time.
And I do actually want to emphasize, I think certain aspects of the Cuban culture actually perhaps lend itself to this more innovative approach. I think because of the nature of what's happened with transportation in Cuba, cars that should not be functioning anymore have been given life well beyond what they're meant to and well beyond their intended purpose. I think certain parts of the Cuban culture are perhaps way more adept at adapting to some sort of alternative use for a vehicle that really perhaps on paper you might not imagine that was its initial function, and taking it beyond that and imagining a different usage of that. So yes, there are aspects of culture that can be barriers, but if you think about it in a different light, I think that can actually make it perhaps much more acceptable and much more exciting, and actually using that to your advantage rather than scrapping an idea from the start because perhaps culture might be difficult. I think it's an opportunity actually.
Thank you.
Thank you, Bert. I want to go ahead. Thank you. I want to go ahead and thank the team from the University of Alabama, Crimson Transit. And at this time, we're going to go ahead and take a 15-minute break and meet us back here at 10:45. And we'll start with the next team right thereafter. So thank you so much.